12 learners, welcome to today's technical mathematics lesson. My name is Matshidiso Kongwani. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Okay, grade 12, our topic today is differential calculus. Under differential calculus, we'll be looking at optimization and the rates of changes. And then the objectives of today's lesson: after the completion of the lesson, you will be able to solve practical problems concerning optimization and rates of changes, including calculus of motion. So under the application of differential calculus, as we will be looking at optimization, and then when we talk optimization, we are talking the maximizing and minimizing problems, or maxima and minima problems. And then on this particular topic, we are referring to the perimeter of shapes, the area, surface area, and the volume of the shapes. It can be a 2D or 3-dimensional shape. And then we have terminologies that we use under this specific topic. So when we talk perimeter or the circumference, remember on a circle we don't talk perimeter, but we talk circumference of a circle. That means we are talking the distance around a shape. For example, if you have to fence the area around your house, that is the perimeter of the house that you'll be calculating in order to know the size of the fence that you need for that particular area. Or if you are putting a fence around a circular area, that means that distance around that shape will be a circumference. Around a circle is a circumference. Any other distance around the shape is the perimeter. It's only a circle that is having a specific name, which is a circumference. And then what is an area now? An area is the amount of space inside a flat closed surface. Inside a flat closed surface. And the total surface area now, for example, if you are having a box, and then now you dismantle this box into a flat surface, and then you now calculate the total surface area of that particular box now being a flat surface or a net area of that particular object. So the total sum of areas covered by surface area of the object, we call it what? A total surface area. And then the volume is the amount of space enclosed by any 3-dimensional object. That means now it now forms a container where you can pour some liquid inside or some quantity inside that particular container. Then that object now, a 3-dimensional one, we call it a volume. The amount of space inside that container is a volume. So we have different shapes, the 2D shapes and the 3D shapes. And then when we talk dimensions, we are talking the length, the breadth, and the height, or length, width, and the height. Remember, sometimes they say a breadth or a width. We are referring to the same thing, grade 12. So now when we talk 2-dimensional shapes, we are talking a shape that is having 2 dimensions. And then for a square, now we are having side by side here, since you know that square is having all sides equal. So now a side by side is 2-dimensional. That is why we say a square is a 2-dimensional. And then when you talk a triangle, now you are having a base there, and then now you'll be having a perpendicular height there. Then that is a 2-dimensional also. It's having a height and a base. And then now when we talk rectangle, we are having the length, and then we have the breadth. And then remember, with the rectangle, 2 sides, opposite sides are equal. And then also the breadth will also be equal there. And then this is also a 2-dimensional shape because it's having a length and a breadth. And then with the circle now, remember now we'll be having pi r squared. For this one, we are referring to the radius of a circle. And then this one again falls under a two-dimensional shapes, because it will be, when you calculate the area of this one, you'll be talking to pi r squared. As you can see, we have a square identity there, therefore it's a two-dimensional shape. And then when you talk to three-dimensional shapes, now you are having a cylinder, a cube, a perimeter, a pyramid, a triangular prism, a cone, a cuboid. A cuboid is a rectangular prism. It comes from a rectangle, therefore we call it a cuboid. Sometimes they call it a rectangular prism. And then we have hexagon prism, we have a sphere, we have a hemisphere. Those are the examples of the three-dimensional. If you look at the cube is from a square because it has a square base there. Remember, a square is having all sides equal. That means the length will be equal to the breadth. And then now we have added a height there. Then the height will be the same. As you can see that for a cube, everything is equal. The length, the breadth or width, and the height is equal there. Okay, so now if we talk a three-dimensional shape, you must have three sides there inside in that particular container that you are talking to. For example, if you look at the cylinder here, it's having that part of a circle, which is a two-dimensional, because now we have added a height there to that container. Remember, there's a base there, circle, base, and then we have added a height, therefore it is now a three-dimensional, no more two-dimensional shape. And then with the triangular prism, we're having a triangle here, and then now it is now having a height there. Okay, can you see now we have added a third dimension to those particular shapes. And then now let's understand the dimensions now. We have one-dimensional, two-dimensional, and the three-dimensional. When we refer to one-dimensional, it's when you talk a length of a certain shape. That means it's only one. For an example, if I can draw a line here, looking at that length of the line, that means this is a one-dimensional, because it's having only from that point to that one, no any other side. So we are talking perimeter, the circumference, it's one-dimensional. And then when you talk two-dimensional now, it's when we are talking the area or the surface area, where we are having a shape now, and then we have length and breadth. Now we are referring to that inner part there. Therefore, this one is a two-dimensional. Okay, and then as you can look at the units there, it is calculated in square millimeters or a square centimeter, or we have a square meter or a square kilometer there. But when you look at the length there, we only talk to the distance, length, the perimeter around the shape there is not a two-dimensional, because you only add the distance around that shape. It's either in millimeters, centimeters, in meters, or in kilometers, depending on the size of the shape that you are referring to. And then when you talk three-dimensional, we talk to the volume of a container now. That is a three-dimensional shape. And then when you calculate a volume, we use the units cubic millimeters or cubic centimeters or the cubic meters or cubic kilometers, depending on the size of the container. And then the capacity now, how much can a container hold? That means you are having a 1 cubic centimeter container or a 1 cubic meters container. And then when we are converting this into millimeters now, a 1 centimeter, a 1 cubic centimeter is equal to 1 milliliters. And then if you convert a cubic meters to liters, 1 cubic meters will be equal to 1,000 liters kilograms. So those are the conversions that you must always remember when you are doing your calculations. And then now let's look at the formula that we are using for different shapes for calculating a perimeter and the area. So that means we'll be involving those two-dimensional and three-dimensional shapes here. Right, with the two-dimensional shape, so if we refer to the first shape there, what do we call that shape? Grade 12, where you are having all the sides equal. That is our square. And then if we are looking at the perimeter of a square, remember a perimeter is a distance around the shape. In this case,
Excellent. Excellence is a habit. Excellence is a quality you have, a quality I have. It's a quality we have when we honor what is true to us. Yes, we are gifted differently. uNkulunkulu akasininganga ngokufana. Excellence is striving for your best. Whenever you have a particular project, test, homework, uzibuze, ask yourself, is this my best? Can I put in more effort? Excellence is striving to be in the top 1% of the area in which you are gifted. And so I challenge you, in every single thing that you do, in every single area that you're gifted in, whether it's sports, it's academic, ucula, whatever that gift is.
okay, grade 12s, the first shape here, we are having a square. How do we know it's a square? All sides are equal. How do we know they are all equal? Is because they have indicated the same size here. We have A for each side then. We have A for each side, grade 12s. Therefore, if we have A, our perimeter now will be A plus A plus A, because we are talking the distance around that shape. As you can see now, we have A plus A plus A. That is why we end up with P equals to 4A being the perimeter of that particular square. And then now when we look at the area of that square, remember an area is a two-dimensional calculation now, where we have A times A is always, when we have a square of a rectangle, the calculation of the area takes a length times breadth. But now with the area of a square, our length and breadth, they have the same value, which is A times A. That is why we have an A squared there, or a side squared, because it's an area of a square. Now when moving to the perimeter of a rectangle now, how do we know it's a rectangle? The two opposite sides are equal, and then with the angle of 90 degrees at the corner there as indicated. Now that means this side is also an A side, and then this one opposite B is also a B side, because the opposite sides are equal of a rectangle. So grade 12, it is very important also to know your properties of your polygons or quadrilaterals. Okay, now let's look at the perimeter of this particular rectangle. A perimeter is a distance around the shape. So if you look at this now, the perimeter around this distance around this one, we are having A plus a B side plus another A plus B there. So now if you look at this now, check like terms, we have A plus A, that is why we have a 2A there, and then we have a B plus B, that is why we have a 2B there. So the perimeter will be 2A plus the 2B, that is the distance around this shape. And then now we take out a common 2, grade 12, so we end up with perimeter being equals to 2 into A plus B there. And then now moving on to the triangle, and then this triangle, now we have side B, side D, side H. It's a scaling triangle. It's a right angle triangle, but all sides are not equal, okay? All sides are not equal. And then we know that a triangle with sides not equal, we call it a scaling triangle. But in this case, it's a specific one because it's having a 90 degrees. Therefore, it's a right angled triangle. So now when you calculate the perimeter, remember a perimeter is a distance around the shape. That means now the perimeter for this will be B plus D plus H as indicated there. Right, with the circle now again we are talking the perimeter of a circle, but it has a specific name of which is the circumference. Now the circumference of a circle is having a specific formula of which is 2 pi r. Grade 12, always remember circumference of a circle, that is the distance around this circle, is 2 pi r. You always use that formula depending on the r of which is the radius of that particular circle. A radius is a distance from the center to the circumference of a circle, and it can be anywhere around that circle. As long as it's from the center to the circumference, know that it is a radius, and the radius is equal throughout the circle. It doesn't matter where you have your radius, this radius will be exactly equal. And then now let's look at the area now. Let's start off with the area of a triangle. The area of a triangle, it will be half of its base. That means we are depending on the side, grade 12, with the perpendicular height, then we'll be taking that perpendicular. In some cases, you'll be having a triangle drawn like that. This will still be your base, but the height must be of perpendicular one. We will be talking to the perpendicular, or you can take it from that side there where you have a perpendicular height. Sometimes it can be a triangle slanted, like maybe you have a triangle drawn in this format there. So we can't take a height there, but the base will still be that one. So, but the height will be the one that is perpendicular there. It must always be a perpendicular height. It doesn't matter the type of a triangle you have, okay? And then now with the area of a circle, as you can see now, the circumference was 2 pi r because it's a one-dimensional, but with the area now we are having a pi r squared because we are talking the area now. As you can see, it is a squared identity there. Therefore, this is now an area. How do you know the difference between the two? The one for the areas must have an exponent 2 because now the unit for an area is a square unit. 3D shapes. Now we are looking at the surface areas and the volumes of these prisms. The first prism is a cube prism or a square prism, which we call it a cube. It's a square prism, grade 12, we call it a cube, like the ice cube in your fridge. And then now it's having 3 dimensions now, which is the length, the breadth, and the height. And then now to calculate the total surface area of this shape is like now we are cutting all the sides to be a flat surface because we are looking at the area there. And then when we cut this off, you'll be having for around the shape, you'll be having the left box, the front one, the right hand side one, and then the one at the back there. And then you'll be having the bottom part and the top part there. So that is the shape that you'll be having when you cut off this into a flat surface now. And then now let's check grade 12. So how many squares do you have now? When you cut this to be flat, you'll be having 1, 2, 3, 4, 5, 6. That is why we are saying we have 6 side squared, because now it's a side by side for each square. Therefore, the area of a square is a side squared, because it's s times s. That is why we are having total how many? 6 of them, of what? Of s squared there. And then when we talk the volume of this, the volume, look at that, the volume is the area of a base you multiply by a height. So since the volume of the base, remember our base here is a square base, and the volume of a base, in this case, it will be side by side. So that will be s squared. So if we are taking the volume of the whole container, we need to look at the area of a base times the height. What is the area of our base now? The area of a base will be s squared. And then the height of this, because it's a cube, it is also s. So now we'll be multiplying by s. That is why we end up with v being s cubed for a cube. And then now let's go to the rectangular prism now, of which we call it sometimes a cuboid. We still have a length, a breadth, or sometimes they say a width, and then we have the height of that container there. And then now if we want to calculate the surface area, remember we have the below part there, of which is exactly as the top part there. So now if we want to calculate the total surface area, we'll be having 2 of the same, of the top and the bottom. And then if you look at the bottom is length by breadth, and then we'll be having 2 length by breadth plus the breadth by height. We are taking the left and right side now, then that one will be 2 of what? Breadth by height. And then plus the last one, we are having the front and the back side there. Okay, we are having another side of which we can't see now because of the view. And then now that one will take what? The length times the height. It will be the length by height there for that one. So how many do we have? 2 for the front and the back. 2 length by height. So now from that information, grade 12, we have now taken out a common 2. And then if we take 2 out there being common, so we'll be left with the LB for first one plus BH second one plus LH for the third one. So this is the original equation of the total surface area of a rectangular prism. Please keep this in your mind. And then now when we talk the volume, remember we talk to the volume of a base multiplied by height in order to find the volume of this. What is the volume of our base? Our base in this case is a rectangle. Can you see that, grade 12? Of which the area of that base is length by breadth. That is why we are having that LB there for length by breadth. And then multiplying by height then is now an LBH, because we have added a height to the area of a base. And then now moving on to the cylinder. Cylinder, we are talking your can of Coke and so forth, those type of containers. And then remember this one, the total surface area now. If we cut off this to a flat surface, we'll be having a circle on top there for the top part, and then we cut the cylindrical part there, it will form a rectangle like, and then the bottom part will form another circle there. So now, if you look at the part that we have cut here, it belongs to this circumference here, because it's like we are cutting off one side there. Can you see that this side is created by this circumference? So now, grade 12, that means the height of a container is still this height, and then the radius of that circle that we have cut off, we will still have our radius there. But for this length of the rectangular part, we are talking to 2 pi r, of which is the circumference of that container. So this is the part that you are having after cutting. Okay, the net diagram of that container. And then now when we want to calculate the total surface area of this one, that means we will be talking to what now? the area of the two circles, first and second, and the area of a circle is pi r squared. So we end up with what? 2 pi r squared for the two circles. And then now for the area of a rectangle formed by this cylinder, now it will be a length by breadth. What is our length this time? Is the circumference, of which is 2 pi r. The length will be presented by 2 pi r multiplied by the height, of which is the height there. So we end up with 2 pi r h for that particular part. And then that means the total surface area for a container or a cylinder container, that will be 2 pi r squared plus the 2 pi r h. That is the original equation that you'll be using for total surface area of a cylinder. It depends, grade 12, if that cylinder is an open cylinder, that means you'll have only one circle instead of two. I hope you understand that part. And then now talking to the volume, remember a volume, it takes the area of a base. What is our base there? Our base is a circle. That is why we have pi r squared. The area of a base is pi r squared multiplied by the height of the container. As you can see, we have added a container there. So we end up with volume being equals to pi r squared h there. Right, and then we have the cone, the surface area of a cone will be pi rl multiplied by pi r squared. And then the volume of the cone will be 1/3 of pi r squared by h. And then this L here, it is representing the slant height, grade 12. Do not mix your height, ne? And then this height here, h, is the perpendicular height, of which you use it when you calculate the volume. But when you calculate the total surface area, we are referring to the slant height, of which is this height of the cone. The slanted height is the one that we use for total surface area. For the height of the volume, we use the perpendicular height of the cone there. Do not mix the two, grade 12. You must be careful when you are calculating them. And then now with the sphere, the total surface area will be 4 pi r squared, and then its volume is 4/3 pi r cubed. That's the volume. And then do not confuse these two, grade 12. Most of the time you are confusing the two formulas there. Okay, make sure that you can differentiate the volume of a sphere from the volume of a cone. Of a sphere, it must be r to the power 3, because the formulas will be given to you. Colleagues' formula will be given to you in a formula table, but you must be able to identify which one is the correct one. Okay, and then now with the pyramid, we have the total surface area, that will be the area of the base. So we are talking the area of a base. In this case, since we have the rectangular base here, that means it will be length by breadth. But that is not always the case. The base can be a triangular base, it can be a square base, depending on the shape that you are having there. And then now plus the sum of the area of triangular sides. That means now, since here we are having an area that is a rectangle, so our prism will compose of 4 sides. That will be the first one. And then we have the second one for that side. And then this side and that one, they are holding 2 same identical ones. So we are having 2, the front and the back one from the pyramid there. So we'll be having the triangular sides. How many? 4 of them, because they come from a base that is having 4 sides there. So then we'll be having 4 area of the triangular base for this one. So you add everything, grade 12, that will give you total surface area. And then with the volume, now we are having 1/3 area of a base. In this case, it's a rectangle. It will be 1/3 of LB times the height. So it's 1/3 LB times the height perpendicular height of that pyramid. Not a slant height, grade 12, but a perpendicular height. So grade 12, you must be able, as you can see also, this one is confusing with the volume of a cone because both of them are having the 1/3. Okay, but you must be able to differentiate. If it's a cone, it must have an R squared there. Right, let's start with the activities now. At least you have a clarity in terms of the formulae of the perimeter, the area, total surface area, and the volume. Now, let's attempt the questions now. A farmer wants to fence off a rectangular shape. So it is given that we are dealing with the rectangular field. That is very important, grade 12, to know the shape that you will be dealing with so that you can select the correct formula. And then now the fence that is available is using 100-meter fence. So if a farmer wants to fence off a rectangular field, that means somehow you are having a field that is a rectangular one. And then around this field, you want to use a 160-meter fence to fence this area. And then remember, if it's a rectangular one, the opposite sides will be equal. Now, the first question wants us to address if the length of the rectangle is x meters. That means now the length is x is the same as that one is x side there. Determine the breadth of the rectangle in terms of x. So this is our length, which is equal to x. Now we want to determine the breadth of this now also in terms of x. How do we do that, grade 12? What is given to you is very important. What is given here is the total fence available. And this fence, you want to put it around this shape. So if we talk around the area, what is that, grade 12? That is a perimeter because we are talking around the shape. So now we are depending on what is given to us, of which is a perimeter. Right, do you still remember the perimeter for a rectangle? That is 2L and 2B. 2L plus the 2B. That will be the area around that shape. What is the perimeter? Yes, it is given to us being 160 meters. We'll look at the units later on. And then what is the length of this? The length is given to us as being an x there. They said the length of that rectangle must be x meters. So we let that be x. And then now we need to find the breadth in terms of x. So look at this, grade 12. You are looking for the breadth, not 2b. So we are going to transpose this 2x to the side. It will be 160 minus the 2x equals to the 2b left on the right hand side. But we don't need 2b, we need b. So we are going to divide each and every term here by 2 to get rid of this 2 here. So our breadth will be how much? 160 divided by 2 is 80 minus the 2 goes once there, we'll be left with x. Therefore, grade 12, happy now? Our breadth is equal to 80 minus x. We have answered the first question there. So with the second one, 1.2, they say write down the equation for the area of a rectangle in terms of x. We are looking at what now? The area of the rectangle in terms of x. What is the area formula for a rectangle, grade 12? That is the length multiplied by breadth. And then what is the area in terms of x now? The length is how much? The length is x. And then we are multiplying with the breadth. We take the breadth, the one that is already in terms of x, because our answer must be in terms of x. So our breadth in terms of x is 80 minus x. So the final simplified area formula for the area in terms of x, it will be 80 times x, that is 80x. And the x multiplied by x will be a minus x squared. That is our equation for the area of a rectangle in terms of x. I hope we are still together, grade 12s. Moving on to the next question, and then the 1.3 on the same question of 160-meter fence. They say, what are the dimensions of the rectangle that will result in what? In a maximum area. Remember, we have our formula for the area that we have calculated in 1.2 in terms of x, and then we have just indicated that our area is 80x minus the x squared according to the previous finding in 1.2. And then from this area now, they say find the dimensions. Dimensions, they mean the length and the breadth that will result in what? Maximum area. The minute we see the word maximum, what comes into our mind, grade 12? Derivative. We must derive the area. So the derivative of this area will be what? Do you still remember the rules of differentiation, grade 12? If it is to the power 1, you take the coefficient 80. And then for this one, it's an exponent multiplied by coefficient minus 1 times 2 is minus 2x. And then from the exponent to subtract 1, that means this is to the power 1. That is our derivative. But we are not looking for the derivative. We are looking for the dimensions of this particular triangle. Dimensions, we mean what? We are looking for the length and the breadth of that particular rectangle. Right. Remember, we have our rectangle there that we are fencing, of which we have length equal to x, and then we have the breadth that was given to us as what? Grade 12. We are having the breadth from the previous one. That means we have calculated that being in terms of x, we have 80 minus x there. Okay, and then we ended up with that area, and then which lead us to that derivative. So to find the real dimensions now, the values of b and the value of l, we need to solve for x here. Can you see that? Because now we need x there. In order to solve for x, we are going to let this derivative be equal to 0. Same method that you apply when you sketch a cubic function. So this will be 80 minus 2x. We are solving for x now. We are going to transpose the minus 2 to the left. This will be positive 2x equals to 80. We are not looking for 2x but a 2. We are going to divide both sides by 2. Therefore, 2 goes once, x will be equal to 2 into 80, which is equal to 40. So what are the real dimensions now? Therefore, the length is equal to x, which is equal to a 40. So the value of this length is now 40. 40 what? Meters, because we were working with meters then. And then now for the breadth, our breadth is 80 minus x, but we do have the value of x now, of which is equals to 40. We will now say 80 minus a 40, which is also giving us a 40 meters. Okay, grade 12. If our breadth now is equal to the length of which is 40, that means this rectangle is a what? A square. Is not a rectangle, it's a square, because all the sides are equal. All sides equal. What type of a rectangle is that? Therefore, it's a square rectangle. 1.4. Hence means using the previous information. Now calculate the maximum area. We now know the values. Now we need the maximum area. We have two ways of doing this, grade 12. You can just go straight, oh, now I know my length and breadth is 40, 40. I can say the area of a square is the same as the area of a rectangle, length by breadth. And then what is my length is 40 multiplied by 40 there. Therefore, this one will give how much? 1,600 square meters. That is the area of that particular maximum area of the rectangular field. Or you can use your area formula there. Our area, remember, was area in terms of x, of which was 80x minus the x squared. That is the initial area formula. So now if we want to maximize the area, we are going to take the x value that is maximized. Therefore, it will be A at 40. So this will be 80 into 40 minus the 40 squared. And then grade 12, you put this into your calculator, it will give you the same value, 1,600 square meters. Those are the two alternative solutions that you may apply to find the 1.4. Okay, let's move on. The next activity, a rectangular area is to be enclosed between a wall and a fence now. Remember with the previous activity, we were fencing the whole rectangle. In this case now, they say now one part of this is a wall. So now, as shown in the diagram, the total length of the fence is 120. We now have 120 fence, but we are not going to fence this side because this fence will be attached to that wall there. So we'll fence only 1, 2, 3 sides there. That is the difference between this activity and the previous one. No more 4 sides, but we are now fencing 3 sides here. So now the 2.1 show that the area between the wall and the fence is given by A equals to minus 2x squared plus 120x. But grade 12, remember, you always start from the given information. If you look at the given information, we are given the total length of the fence, of which is 120. So there's no way we can go straight area without applying the perimeter there. This perimeter will assist us now to change one of the variables there. Let's say we are changing y to be in terms of x, because the area is in terms of x. Do you get that? Because if you can try to just go to the diagram and say, oh, the area will be a length by breadth of which is y times x there. So we'll end up with the area that is xy. Will this help us? No, because now we are looking at the area in terms of x only there. That simply means we need to change this y and write it in terms of x. I hope you already know how to do that because we did this on our previous activity. So we are going to start work grade 12 from the given. What is given? Perimeter. What is the perimeter now for this particular diagram or situation? We are having x plus x, which is 2x, plus y will only take 1 because the other side is a 1. So now let's substitute the total fence we have 120 meters. 2x plus y. We need y, we are going to transpose 2x to the side. Left hand side, it will be 120 minus the 2x equals to y. We now have y in terms of x. Can we now bring in our equation for the area? Yes, the area, remember we have identified that it will be xy. What is y? Y is 120 minus 2x. So now our area in terms of x will now be what? We are multiplying an x in, is x times 120, that will be 120x, and then x multiplied by minus 2x, that will be minus 2x squared. That is the equation for the area. Does it agree with the what? The area that was given to us there to prove or to show that the area between the wall and the fence is given by that equation? Yes, we are having a minus 2x, we have also minus 2x squared plus 120x and the positive 120x. Therefore, our solution is correct for 2.1. But be careful, grade 12, this is tricky. You can't start with straight area. We need to start from the given, of which you are given what? The perimeter. That is your starting point. And then with 2.2, determine the maximum possible area. We are still doing the same calculation where we identify the maximum area that can be enclosed between the wall and the fence. But to calculate the maximum area, can you see grade 12? We need the value of x there. We can't calculate the area without x. Do you still remember how we calculated an x value? Because this must be maximum, therefore we must maximize to get the value of x. Let's do so. We are looking at the derivative of this area formula. We have just calculated into 0.1. 120x minus 2x squared. So we derive that in terms of x. That means if x is to the power 1, we take the coefficient as derivative, that is 120. And then now the next one, we need to apply the rule. 2 times minus 2 is minus 4x. And then we subtract 1 from the exponent. We are left with x to the power 1. And then we let this derivative be equals to 0 now. Optimizing minus 4x, and then we need to solve for x. We are going to take minus 4 to the left, that will be positive 4x equals to the 120 left on the right hand side, and then we need the value of x. We divide both sides by 4, therefore x will be equal to what? 4 8 12, that is 30 what? Meters. That is the value of x. All right. And then remember now, grade 12, we have said the y side is the same as what? As 120 minus 2x. And then if we say the x value is equal to 30 now, that means this side will be 30 equals to that one also will also be 30. And then now the y side will be 120 minus 2 into x 30. This is 120 minus 60, of which will give you a what? A 60 there. Right. Remember, we have not yet answered the question. The question is looking for the maximum possible area. Up to this far, we have calculated the value of x. So now, the first alternative method, remember we have 2 ways of doing this. Since we know the values of the sides, we can apply the area is equal to length by breadth. What is our length? 60 multiplied by breadth 30. And then this will give us what? 1800 square meters, because we are calculating an area. Or alternatively, grade 12, you can use the formula that you have identified there as being the area in terms of x of 120 x minus 2x squared. And be careful, grade 12, we are using the original equation. You can't use the derivative to find the area. We do not use the derivative to find the area. We always use the original. Derivative is for finding the value of x only, right? And then now from here now we can substitute the value of x, of which is 30, 120 into 30 minus 2 into 30, that is squared. No matter what, grade 12, this must give you exactly the same answer as the previous application. So the area of this at 30, at x equal to 30 will be 1,800. You can verify that using your calculator. Okay, number 3. And then with the third activity now, we are given the diagram, and this diagram shows a rectangular box, as you can see there, with the following dimensions. We have the length, which is equal to 5x, and then we have the breadth, which is equal to 9 minus 2x, and then we have a height, which is equals to x. And then they say determine the volume of the box in terms of what? Of x. Grade 12, it is of importance to you that you know your formulas, okay? So now you must know what is the formula of a box. The formula of a volume of a box is V of a box equals to the length time is breadth, time is height. And then now let's substitute now. What is the length? 5x. What is the breadth? 9 minus 2x. What is the height? The height is x. And then now we need to multiply and simplify this. We can start with an x, maybe x by 5 there. That will be 5x squared. And then we can now bring in the 9 minus 2x to make life easier. And then 5x squared multiplied by 9, that will be 45x squared. And then 5x squared multiplied by minus 2x, that will be minus 10x to the power 3. Therefore, that is the volume of that box in terms of x, grade 12. That is the expectation from that particular question. And then now the 3.2. With the 3.2, they say determine the value of x now, for which the box will have a maximum volume. We are not calculating a maximum value, but what are we calculating? The x for which the box is maximum. Now, that means they are telling us we need to take this volume formula and then derive the formula. So when you derive, it will be 2 times 45, that is 90 x to the power, we minus 1, it will be to the power 1. And then for the next number there, we have 3 times minus 10, that is minus 30 x, and then we subtract 1 from the exponent, that is to the power 2. So we are applying the rules of differentiation, grade 12. And then now, since we are maximizing to find the value of x, we are going to let the derivative of v equal to 0, and then we have 90x minus the 30x squared. And then from here now, you can take out the common factor, or you can divide throughout by 30 there. So if we divide by 30 to simplify this, you are going to end up with the still 0 on the left, and then 30 into 90 is how many times? 3 times. And then the 30 into 30 once, then you are left with x squared there. And then from here now, grade 12, can you see now you have a common factor x there? So we are going to take out that common x. So now when you take out x being common here, you'll be left with 3 from this one. 3x divided by x is 3. And then minus the x squared divided by x, it will be x equals to 0, remember? And then therefore, the first x here will be equal to 0, or from the bracket, the 3 minus x will be equal to 0. Therefore, minus x is equal to minus 3, then x will be equals to 3. Those are the two x values, grade 12. X equal to 0 and the x equals to 3. Now, can we accept x equal to 0 to maximize the volume? Remember, we want the biggest volume ever for that particular container. So if we say x is 0, that means if you put a 0 here, you'll say length is 0. If you put a 0 here, you'll say breadth is 9. And then the height is 0. Is it possible that we can have dimension 0, 0 on a container? No. That means this x is not acceptable as our answer. So the final answer will only be what? X equal to 3. So grade 12, this simply means after calculating, verify whether your answers will be applicable to the type of question that you are having. There's no way you can have a side of a container being a 0. Okay, that is why we are cancelling x equal to 0 to be our answer. Right, the diagram shows a square-based box. That means we are talking to this base here. We are calling that the base because that is the part that is the container is balancing on. And then now, which side of base being an x is indicated the xx, The volume of a box is 24 cubic meters. That means the inside of this box capacity is 24 cubic meters. It's a very big box, né? And then now show that the height of the box is given by h at x equal to 24 over x squared. The answer is given to you. Yours is to show us in terms of calculations how will you end up with 24 over x squared. Remember the tip around optimization. You always start from what? The given. What is given to you is the volume of a box, which is 24 cubic meters. So now your starting is of volume of a box. The volume is LBH. That is the starting point. What is the volume now? Volume is given to us as 24 cubic meters. We look at the units later on. And then the length and the breadth will be the same because the base of the container is a square. It's a square-based box. So now the length will be x, the breadth also x, and then the height, we don't know the height of the container, it will remain h there. And then now this gives us 24. X by x is a 2x, it's an x squared multiplied by h. But now we are looking for h in terms of x. So we'll divide both sides by x squared because we are looking for h. So now we'll be left with h there, and this will be 24 over x squared. That is our h in terms of x. Is it correct? Yes. 24 over x squared as indicated to prove that, to show that is the answer. Moving on, number 5, we have an open box now. This box does not have a lid as is indicated on the diagram there. Okay, and then it has a volume of 480 cubic centimeter, a height of 4 centimeter, breadth of x centimeter. And then can you see we don't even have the length there is L centimeter. So we have 2 unknowns there already on the diagram. But let's look at what is given. You are given the volume, and then you are also given the height of the container. And the breadth is in terms of x, and the length, we don't know the length there. And then they say show that the total surface area of the box is given by that particular formula. The total surface area of the box. So grade 12, we must start first, because if you look at this, everything here is in terms of x. And then now when we look at our dimension for 4, we are fine. We have x, we are fine because it's in terms of x. So we have a challenge of that L, because this length now is not in terms of x. That means that must be your starting point, because now if you try to say the area of this box, maybe you are cutting and forming the net diagram of this, you will have a challenge of this side because it will also be represented by L. So we need to take care of that before you can continue. What is your starting point? We can't start straight from the area because we are given a volume. So we start from the volume of a box, of which is LBH, length by breadth by height. And then what is the volume? The volume is 480 cubic centimeters. What is the length? We don't know. The length is represented by L. What is the breadth? The breadth is in terms of x. And then the height of the container is 4 centimeters. So this gives us 480 equal to 4x with the length there. So can you see grade 12, you can find your length now in terms of x? Yes, by dividing both sides by 4x. So our length will be 480 divided by x, and then 4 into 480 is 120. So below will only be left with x there. Okay, so that is the length in terms of x. But we are not looking for length. We are looking for the total surface area of this box. Happy now, everything is in terms of x. We can now predict the flat net diagram of this box now. If we cut this box here on the edges, we will be having 1, 2, 3 sides there, okay? That means we'll be having a rectangle there, another rectangle here, and the third one there. And then we'll be having the side ones there, okay? That is the shape of the flat container. We can't have the fourth one because the top part is open. If it was not open, we will be adding another diagram here, okay, for the top part. So in this case, we are having 1, 2, and the third one there. And then for the sides, we have these 2 sides here, okay. Now, we want to identify the dimensions for this now. For the left part, for this one, we are having the x is the same as this one. So it's x multiplied by 4. Okay, how many of that? 2 of them. Right. So now let's predict the formula for this one. Is the total area, total surface area of this will be equal to, for the left and right of the box is the same size. So we are going to have 2 times what? X times 4. Okay, we are done with that one. And then for the front and the back, we have the same size. So how many of them? 2 of them. What is the dimension for that? Is length times height. But you already know our length, right? Or let me put it in length and height for now. And then the length and the height is 4 there. And then plus, we can't say 2 now. For the bottom and top, we can't say 2 because the top part is open. So we'll have only 1, which is the bottom one. So with the bottom, we have L by X there. So this brings us to the area being 8x for the first part. And then for the second one, we are having 2 times 4, which is 8. And then with the length, what is our length in terms of x is 120 over x. Plus, we have our length times x, that will be x into the length of 120 over x. So now, simplifying that, we have 8x plus 8 times 120, and then this will give us 920 over x, and then this x goes once there, we'll be left with only 120 there. Let's check now grade 12. This is 960, sorry, 960 there. And then let's check now versus on what we need to prove. 8x is there, 960 over x, and the 120 is there. That means this is the correct total surface area for that particular shape. That is the 5.1. And then with 5.2 now, we need to determine the value of x for which the total surface area of the box is a minimum 1. Round the answer off to the nearest centimeter now. So now, the minute they say this is minimized, that means we need to derive to find the value of x. So we are deriving the area. If it is to the power 1, we take the coefficient 8. And then this 960 over x, remember it is actually 960x to the power minus 1. So if we are deriving that, that will be minus 1 times 960, that is minus 960. And then x to the power minus 2 there. And then 120 is a constant value, it gives us a derivative of 0. So now we let this equal to 0, derivative of the area, because we are solving for x. And then this will be 8 minus 960 all over x squared. All right. And then now our LCD is x squared. For this to be a quadratic equation, we are going to multiply throughout by x squared. So 0 times x squared is 0. 8 times x squared is 8x squared minus 960 over x squared times the x squared, it will be minus 960 because that x squared will cancel this one. Okay, and then now we have an equation like that one, and then now we transpose 960 to the left to be positive. That will be 960 equal to 8x squared. Divide by 8 both sides. We are having an x squared that is equal to 120. And then this side loses an exponent 2. This will gain plus minus the square root, but we cannot have a length that is negative. So this will take only the positive square root of 120. And then the answer say round the answer off to the nearest centimeter. So this x value is actually giving us in decimal form, that is 10,95. And then if we round this off to the nearest centimeter, it will be 11 centimeters. That is the value of x for this particular box. Okay. Another activity. As you can see, grade 12, we are unfolding different types of asking these questions, okay? From the level 1 up to the highest level. And then in this case, we are having a rectangular poster. This is the poster that we are having. And then has a printed picture. Our whole poster is this one. All right? And then now it has a printed picture. The picture that is printed is the shaded part there, in the form of a small rectangle, as you can see in the diagram. And this picture is having an area of 72 centimeter squared. And the following margins are required around the picture. As we are designing this picture, and then the margins must be 136 centimeter, as you can see, top and bottom there. And then left and right, it must be 2 centimeters as indicated there around that picture. Okay, now note that now we let x and y be the breadth and the length of the printed picture area. So we have x there and the y to be the breadth and length of that particular picture. So determine the dimensions of the poster, not the picture, of the poster. We mean the whole thing in terms of x and y. So look at this now, grade 12. If I'm taking the whole side there, the breadth of the poster, so can you see now the picture is having x here, but for the poster now I will be adding that one there and another one there. So it will be x plus 2 for the poster. And then for the length of the poster there, I'm having a y from the picture there, but this is adding 2 centimeter on the side there. That means it will be y plus 4 centimeters for my poster. So now we want to determine all these dimensions must be in terms of x, not a y. Okay, so that means you need to get rid of this y and write it in terms of x. So how will you do that? You'll go back to the picture now, because you have the area. We always start from what is given. We are given the area of what? Of the printed picture. So now we have the area of the printed picture. So the area of the picture now is the length by breadth, and of which is x by y. And then the area is given to us as being 72, and then of x by y. But we are looking for y in terms of x. That means this will be 72 over x when we divide both sides by x. So this is our y in terms of x. So grade 12, if they say determine dimension of the poster in terms of x. Our poster dimensions now will be the length of the poster will be y plus 4. What is the y? 72 over x plus 4. That is the length of the poster in terms of x. And the breadth of the poster in terms of x, it is already in terms of x, of which is x plus 2. That is the answer for 6.1. With a 6.2, they say show that the area of the poster, not the picture, because the area of the picture is given to you as 72 square meters. We are looking for the area of the poster, including the margins now. You are showing that the area will be given by this formula now. That means we are determining the area in terms of x, right? The poster is also in a rectangular shape. That means we still use the equation of a rectangle, which is area of a poster is equal to the length by breadth. What is the length of the poster? We have already calculated that in terms of x. We ended up with 72 over x plus 4. Then we are multiplying this with the breadth. What is the breadth? The breadth is x plus 2. Simplify the bracket now. We are multiplying 72 with an x. The x will cancel x. We are left with 72 there. 72 over x multiplied by 2, that will be 144 plus 144 over x. And then we now distribute 4 to the next bracket. 4 times x, that will be 4x. And then 4 times 2, that will be 8. And then let's rearrange accordingly now. They have started with 4x. We'll start with 4x, followed by 144 over x. Yes. And then the 72 plus 8 will give us a plus 80. Exactly, grade 12. What was expected from us is our solution. Exactly the same as that one. But you need to ensure you understand the language. Do not mix the issues, because the word poster and picture can be confusing to you. Ensure that you are talking to the correct diagram there. And then number 7, we have a beverage company, and this company wants to manufacture a cylindrical can. So we are working with a cylinder now. And then this cylinder can hold 1 liter of liquid, 1 liter of liquid. And then now we need to show that the height of the container can be expressed by this formula. Always start from what, grade 12? From given. But in this case, we are given a capacity of 1 liter. So you start by converting a liter to cubic centimeters. Okay, 1 liter to cubic centimeters. You remember at the beginning we indicated the capacities, right? That if you convert 1 liter, you'll be having 1000 cubic centimeters there. Okay, so now we are actually giving 1000 cubic centimeter there. And then now, since we are given the volume of the cylindrical can, so we are depending on that volume to find the height of the container. So we are looking at the height, we are given the radius there in terms of x. So now we are going to have a volume of a cylinder. Remember, is the area of a base. What is our base? A base is a circle, therefore it will be pi r squared multiplied by height. And the volume is how much? 1000 cubic centimeters pi. What is the radius? The radius is x, therefore it will be x squared with the height. And then we divide both sides by pi x squared, because we are looking for h pi x squared. Then the pi x squared goes once there, we'll be left with h this side, and then on the left hand side we have 1000 over the pi x squared. Is it what is expected from us? Yes, we are 100% correct. And then with 7.2, determine an expression for the surface area of the can in terms of x. We need now an expression for the surface area of a can in terms of x. Do you still remember the net diagram for a cylindrical container? You'll be having a circle for the top part, you have a rectangle for the middle part, and the bottom part you have a circle again. How many circles do you have? 2, with the same radius, right? And remember now, this is the height of the container, and then this side, remember we said when we cut the container there and we unfold this part, that means this circumference here is the length of that middle part. So that means this is circumference 2 pi r. So now we need to find the surface area of this. So when you look at the surface area of this can now, it is containing 2 areas of a circle, and then the area of a circle is pi r squared plus the area of a rectangle, of which is length by breadth, and then that is 2 pi r squared for the 2 circles, and the length of the rectangle in the middle there is 2 pi r, is taking the circumference, that is plus 2 pi r for the circumference multiplied by the height of the container. Okay, and then now when you simplify these great terms, you'll be having, you can leave it like that, or you can substitute. They say it in terms of x. No, you can't leave it like that because you're having an h and r there. You need to substitute that. That is 2 pi. What is the radius? Radius is x squared plus 2 pi. The radius is x, and then we are having a height. You have already calculated that. That is the height of 1000 over pi x squared. Let's continue now with simplification. We end up with 2 pi x squared for this one. And then here, grade 12, the pi goes once there, and the x, take 1x there. So the final is 2. Here we are only left with this 2 here. Multiply by 1000, that will be 2000 over, we are left with that x on the denominator there, that will be over x. So that is the surface area of the can in terms of x there. Okay. Now 7.3, we are still on the same container with 1 liter of liquid. They say determine the dimensions of the can that will minimize the amount of material needed to make that particular can. If you are minimizing or maximizing, that means you are looking at the derivative of the area. Remember, we are having a surface area of this can in terms of x being the 2 pi x squared from our previous calculation plus 2000 over x then. So now if we need to derive this, because we want to minimize the amount of material needed to manufacture the container, we must derive the surface area formula. So before we derive, let's write this in a correct form that will allow us to derive. This will be 2000, so we are taking x up, it will be x to the power minus 1. Then we can now start deriving derivative of surface area in terms of x, dSA over dx, and then now we say 2 times 2 pi that will be 4 pi. We subtract 1 to the from the exponent, it will be to the power 1. Minus 1 times 2000, minus 2000, x to the power minus 1 is minus 2. That is the rule. And then since we want the dimensions, that means we are looking for x and r and the height of the container. And then now we can let this be equal to 0 to be able to solve for x there. And then now we have the 4 pi x minus 2000, write this in a fraction form, vector fraction. This is x squared. And then our LCD is the x squared there. So we are going to multiply throughout by the LCD. If we multiply 0 by x squared, it will still be a 0 equal to, we multiply 4 pi x by x squared, that will be 4 pi x to the power 3. And then we multiply this minus 2000 over x squared by x squared goes once there. We are left with minus 2000 there. Okay, and then transpose 2000 to the left to change to positive, and then we are left with 4 pi x cubed. We are looking for x. We are going to divide both sides by 4 pi. 4 pi. The 4 pi will go once. We are left with x cubed equal to, and then 4 into 20,000, 4 into 20, then we are having 4, 8, 12, 16, 20, that is 500 over pi. So now if this side loses a cube, this one will gain a cube root of 500 over a pi. Or you can write it as it is, the 2000 over 4 pi is still fine, eh? The cube root of that. So now rounding off to the second decimal, our answer will be x equals to 5,42 centimeters. That means the radius of this container is 5,42. That is the first dimension. Remember, we have the x and the height of the container, of which are the dimensions of that container. In order to find height, do you still remember grade 12? We have calculated the height and proved that the height is 1000 over the pi x squared on our previous 7.1. So we are going to substitute the value of x that we have calculated there in order to find the height. That is pi into 5,42 centimeters squared. And then the final answer there will be 10,83 centimeters. So this is the height of the container, that is the first dimension. And then the radius of the container, of which is the x, will be 5,42. Those are the two dimensions of that particular container. And then now we move to the second part of the application of differential calculus. Remember, we said we work with optimization and the rate of change, of which we look at the calculus of motion. Under rate of change, we are having the derivative. We're still going to derive formulas that we'll be working with. And then we let it equal to 0 to find the value of x. And then we'll be looking at the velocity. When we talk the velocity, we are talking the derivative of displacement or a distance. The formula for velocity is v at a certain time. So you'll be looking at the derivative of a distance or displacement of that. Or you can use the notation ds over dt. And then remember, the rate of change is a derivative. Grade 12, right? The minute you see the word rate of change, you must know, you must derive. Né? And then with the acceleration now, we will derive the velocity, the derivative of a velocity. Or you can write it as dv over dt, deriving velocity in terms of t. And then now terminologies that we use under the rate of change, we have the displacement. What is displacement? It's a change of position of an object. These words are having relationship with your technical science. You'll find these words mostly on your technical science. And then when we talk speed, we talk the rate of change of displacement with no particular direction. That means it's a car speeding, but it doesn't matter in which direction does it speeds. And then now the velocity is a rate of change of displacement in a particular direction now. Okay, and then the acceleration is the rate of change of the velocity. The first activity then, we have a stone that falls from a cliff, and that cliff is 300 meters high. And then the distance covered by the stone is falling from a cliff. The distance between a cliff and the ground is 300 meters. And the distance covered by the stone while falling is given by S at t is equal to 3t squared, where S is the distance covered in meters and t is the time in seconds. So the first question there, 1.1, they say determine the speed of the falling stone after 3 seconds. The speed, do you still remember? The speed is a derivative of a distance, right? Therefore, we are going to derive first the equation S at t, derivative of t, and then that will be 3 times 2, which is 6t there. And then now we are looking at the speed. This is now a speed because it's a derivative of distance. This is now speed in 3 seconds now. Then it will be 6 into 3. And then what is the speed there? 6 times 3, that will be 18 meters per second. That means the stone will be falling at a speed of 18 meters per second after 3 seconds. Okay, how long will it take before the stone hits the ground? How long is the distance? Okay. Can you please?
Attitude of gratitude. What does that mean? An attitude of gratitude is the quality of being thankful. It's the quality of giving thanks. Ubonga, ulebuha. It's to be grateful. You and I have so much to be grateful for. You and I have parents who make sacrifices day and night for us to be at school. You and I have people who believe in us when we don't believe in ourselves, who love us when we don't love ourselves, who invest in us day and time again. Whether it's a teacher, it's a principal, it's a driver, it's a guardian, we have so much to be grateful for. And so I challenge you, young person, be thankful, ubonge, lebuha, be grateful each and every single day of your life. Strive to display an attitude of gratitude.
Okay, grade 12s. Now, how long will it take before the stone hits the bottom of the cliff? Remember now, this stone is already falling at a certain speed, all right? So now we are checking how long will it take. So we are still using that derivative formula. But now in order to hit the ground, this must have covered the 300 meters. So we want to see how long will it take. So remember the derivative of this is 60. We have already calculated that. That will be equal to 300 meters. Divide both sides by 6. Then t will be equals to 6, 12, 18, 24, 30. That will be 50 seconds. Okay, that T will be 50 seconds then. Right, and then now we move on to 1.3. What will the speed of the stone be when it hits the bottom of the cliff? Now, we want the actual speed of this after the seconds that we have identified. Then now we take the speed again, of which is 60. And then now this will hit the ground after 50 seconds. That means it will be 6 times 50. That will be how much now? The speed of this stone when it hits the ground, how much will be the speed now? That is 6 times 5. That is the 300 meters per second. Okay. And then now the second problem here, we have the volume of water kettle. The T minutes after it starts to boil is given by the volume of the kettle, and then the volume is measured in milliliters. How many milliliters of water are there in the kettle just before it starts to boil? That means the minute you put in the kettle there, and then now before it starts to boil, no time is detected. Yes, the kettle is passive. We have not yet switched the kettle on. That means now our time will be 0 there. For 86 minus 1 over 8, time is 0. And then minus 1 over 4, the time is 0 cubed. So this will be 86 how many milliliters of water are there? We are having initially, our kettle is holding 86 milliliters of water there. And then now the second one question says, as the water boils now, the volume in the kettle will decrease. Remember, if this is the limit of water at 86 milliliters, the minute it starts to boil, the water will evaporate, and then it will decrease the amount of water that you are having in the kettle. So we want to determine the rate at which, the minute we see the word rate, that means we know that we need to derive the rate at which the volume is decreasing when T is equal to 2. But because it's the rate, we are going to derive the volume formula. And then now 86 is constant, it will be 0. And then the next one is T to the power 1. We take the coefficient minus 1 over 8. And then the 3 multiplied by minus 1 over 4. It will be minus 3 over 4. And then this will be T squared. And then now we are given that we are looking at the rate at which the volume decreases at T equal to 2 minutes. So we'll look at the volume at 2 minutes, and then this will be minus 1 over 8 minus 3 over 4 into 2 squared. And then straight into your calculators, grade 12. And then since this is a decreasing rate of the volume, the answer will be negative due to the fact that it is decreasing. So this will give us a minus 25 over 4 milliliters per minute, of which in decimal it will give us a minus 6,25 milliliters per minute. Why negative answer? Because the volume is decreasing. All right, grade 12. And then this brings us to the end of today's lesson. And this lesson was brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Thank you very much, grade 12.